All right, hello and welcome. Today, we're going to pull back the curtain on how the modern web works its magic. We're going to demystify the whole rendering process that makes the apps you use every single day feel so incredibly fast and smooth.
I mean, think about it, right? You're scrolling through your feed, you like a post, you start typing a comment, and everything just updates instantly. There are no jarring reloads, no staring at a blank white screen. How is that even possible? Well, that's the exact question we're going to dig into.
Okay, so to really appreciate just how elegant things are now, we first have to take a quick trip back in time, back to let's call it the bad old days of web development.
And wow, it was chaotic. Before tools like React came along, developers had to manually, and I mean manually, change every little piece of the web page. This led to what we call spaghetti code because, well, it was a tangled mess. Updating the page was slow, and trying to figure out what the app was going to do next, forget about it. You get these awful bugs where the data and what you were seeing on screen were totally out of sync.
So how do you fix all that chaos?
Well, it turns out the solution was built on a really simple but totally revolutionary idea that just changed everything. And this is the huge mindset shift. Instead of being a micromanager and giving the browser a laundry list of commands like, okay, first find this button, now change its color, then go find that little piece of text over there and update it, React lets you be declarative. You just describe the end result. You say, hey, based on this data, this is what the screen should look like. You tell React the what, and it figures out the how all by itself.
This brings us to the absolute core principle of React, and you can boil it all down to this beautiful little equation. UI equals a function of state. Your user interface is just a reflection of its data, what we call state. So if the data changes, like you get a new message, the UI just automatically reflects that change. That's it. That's the whole idea.
I love this quote because it just nails it. The DOM is basically the live structure of a web page. And the key insight here is that with React, you never touch that live structure directly. Nope. Instead, you just give it a blueprint. It's kind of like telling your GPS your destination, and the GPS, that's React, figures out the absolute fastest, most efficient way to get you there.
Okay, I know. Virtual DOM, declarative, this can all feel a little abstract. So to make it all click, let's use a super simple analogy that I think makes this whole thing make sense. A busy restaurant kitchen.
So let's break this down. A component in React, like a button or a profile picture, that's our chef. The customer's order, that's our data, our state. Now, when that state changes, a new order comes in, the chef doesn't run out to the customer's table and try to change the food that's already on their plate, right? That would be insane. No, they go back to the kitchen and they cook a brand new dish from scratch based on the new order.
And that newly prepared dish, that's what we call the virtual DOM. It's just a lightweight blueprint of what the final UI is supposed to look like. It's not the actual plate on the table, it's the perfect version sitting in the kitchen, ready to go.
Now here is where the absolute magic happens. You've got this incredibly smart waiter. This is React's reconciliation process. The waiter looks at the new dish in the kitchen and compares it to the old one on the table. And they instantly see the difference. Instead of swapping out the entire meal, they see, oh, they just wanted more ketchup. So the waiter only brings out the ketchup. It's wildly efficient. So you can really break this whole thing down into 3 clear steps. First, there's a trigger. An order comes in, maybe you click a button. Second, there's the render phase. That's the kitchen preparing the brand new dish, creating that virtual DOM. And finally, you have the commit phase. That's the waiter smartly delivering only the necessary changes to the table, or in our case, to your screen. But wait a second. Cooking a whole new dish, comparing it, delivering changes, that sounds like a lot of work. How does React do all of this so ridiculously fast that your browser doesn't just freeze? Well, that's where we get to the engine's secret superpower.
It's called the Fiber architecture, and this was a massive, ground-up, complete rewrite of React's core engine. It was redesigned with one main goal in mind, to make rendering so smart it would never, ever block you from interacting with the page.
And this powerful engine wasn't there from the beginning. React first came out in 2013, but for years it worked on a much more rigid system. It wasn't until 2017 that this huge Fiber rewrite was released. It was an enormous project that totally changed the game and made the super responsive apps we use today even possible.
So why is Fiber such a big deal? Simple. It lets React multitask. It can be in the middle of some big, low-priority update, but then something important happens, like you start typing in a search box. Fiber lets React pause the big task, immediately handle your typing so it feels instant, and then go back to its other work. This is exactly what keeps everything feeling so smooth and stops the page from freezing up on you.
Okay, let's bring it all home, because this isn't just about some clever coding trick. This approach represents a fundamental, massive shift in how we actually build software for the web.
I mean, just look at the difference. On the one hand, you have the old imperative way. It looks like a tangled mess because, frankly, it was. You're giving this long, complicated, manual list of commands. But on the other side, you have the declarative blueprint. It's just a clean, simple description of what you want. And that's not just about writing cleaner code. It's about building things that are way more reliable and predictable.
And that right there, that is the entire paradigm shift. We went from being micromanagers, telling the computer exactly how to do every little thing, to being architects, where we simply describe what we want the final building to look like, and we trust the system to handle all the heavy lifting.
This declarative approach has made building apps faster, more powerful, and just plain better than ever before. But it also leaves us with this really fascinating question to think about. If we can build these incredibly complex, dynamic user interfaces just by describing them as a reflection of data, what else can we build with that same powerful idea?